Good morning, students. Suppose f is a real valued function. The function defined by limit h tends to 0, fx plus h minus fx upon h. Whenever the limit exists, wherever the limit exists is defined to be derivative of f at x and is denoted by f dash x. This definition of derivative is also called first principle of derivative. Thus, f dash x is equal to limit h tends to 0 fx plus h minus fx upon h. Today, students, we are going to study the first principle of derivative, also known as ab initio. Let us consider the examples. The first example is fx is equal to x cube minus 27. Fx plus h is equal to x plus h whole cube minus 27. We put it in the formula and get x plus h whole cube minus 27 minus x cube minus 27 upon h. Let us expand. We get x cube plus 3x square h plus 3xh square plus x cubed minus 27 minus in bracket x cube minus 27. On cancellation of x cube and 27, we are left with 3x square h plus 3x h square plus h cubed upon h. Take h common and cancel. We get the function as 3x square plus 3xh plus h square. Put h is equal to 0. The answer is derivative of x cube minus 27 is 3x square. Consider the function fx is equal to x minus 1 x minus 2. Then fx plus h is x plus h minus 1 x plus h minus 2. Then if we put the values in the function, we get x plus h minus 1 x plus h minus 2 minus x minus 1 x minus 2. We can also write it as x minus 1 plus h x minus 2 plus h minus x minus 1 x minus 2 upon h. Now we cancel the functions accordingly and we are left with x minus 1 plus h x minus 2 plus h square upon h. Take h common and put h equal to 0. We get x minus h x minus 1 plus x minus 2 plus h. Put h is equal to 0. We get the answer 2x minus 3 as the derivative of x minus 1 x minus 2. Consider the example fx is equal to 1 upon x square, fx plus h is equal to 1 upon x plus h whole square. Then fx plus h minus fx upon h can be written as 1 upon x plus h whole square minus 1 upon x square upon h. Take the LCM and we get x square minus x plus h whole square x h square x plus h whole square. After solving, we get minus 2hx minus h square. Take h common and cancel with the h in the denominator. We get minus 2x minus h upon x square x plus h whole square. Now we put h is equal to 0. We get the solution, that is minus 2 upon x cube as the derivative of 1 upon x square. Consider the function fx is equal to sin x. Then fx plus h is equal to sin x plus h. Then put the values in the function. We get sin x plus h minus sin x upon h. We note that sin c minus sin d is equal to 2 sin c minus d upon 2 cos c plus d upon 2. Equating according to the formula, we solve it. We get 2 sin h upon 2 cos 2x plus h upon 2. divide and multiply h by 2, we get 2 sin h by 2 cos x plus h by 2 divided by 2h by 2. We can also write it as limit h tends to 0 cos x plus h upon 2 into limit h tends to 0 sin h upon 2 divided by h upon 2. We know that limit h tends to 0 sin h upon 2 upon h upon 2 will become 1. So what we are getting, the derivative of sin x is cos x into 1, that is cos x. Consider the function fx is equal to cos x. Then fx plus h is equal to cos x plus h. Let us put the values in the function. We get cos x plus h minus cos x upon h limit h tends to 0. Now we are using the formula cos c minus cos t is equal to minus 2 sin c plus d upon 2 into sin c minus d upon 2. We get minus 2 sin 2x plus h upon 2 sin h upon 2 divided by h. The derivative will become minus sin x, since sin h upon 2 upon sin h upon h upon 2 will become 1, and in place of h we put 0, then sin x will also become sin x. Sin x plus h upon 2 will become sin x. Negative sign will remain in the function. The derivative of the function is minus sin x. Out of these 4 questions, let us do 2 more questions in the examples. Number 1, fx is sin 2x, then fx plus h is sin 2x plus h. D by dx fx is equal to limit h tends to 0 fx plus h minus fx upon h. Limit h tends to 0 sin 2x plus h minus sin 2x upon h. Now we use the formula sin c minus sin d, that is equal to 2 sin c minus d upon 2 cos c plus d upon 2. We get 2 sin h cos 2x plus h upon h. Now sin h upon h will become 1 and cos 2x plus h will become cos 2x if we put h is equal to 0. So the derivative is 2 cos 2x. Consider fx is equal to sin square x and fx plus h sin square x plus h. Put it in the function, we get sin square x plus h minus sin square x upon h. We know this formula, sin square a minus sin square b is equal to sin a plus b sin a minus b. On the basis of this we get sin x plus h plus x sin x plus h minus x upon h. Now again sin h upon h will become 1 and sin 2x plus h will become sin 2x, and the derivative of sin square x is sin 2x. So out of these 4 example, we are doing 2 and the rest you can do it yourself. The PDF will also be sent to you. There are few questions for practice I am giving you, and these questions you can see it in the PDF also, and you can see it in this video also. You can practice these questions and the answers are also given. You can check your answer. If you have any problem, you are most welcome to ask your problem whenever the schools open. Thank you very much.